The recovery of trees after White Juan in Point Pleasant Park from 2004 to 2023, presented by Nasser Ibrahim, Emily Meldrum, Catherine Kenny. Point Pleasant Park in Halifax, Nova Scotia saw a significant shift in the aftermath of Hurricane Juan's catastrophic 160-kilometer-an-hour wind speeds, passing on September 28th and 29th in 2003. This terrible occurrence damaged hundreds of trees, radically altering the landscape of the park. The destruction was so severe that the park had to be closed for 8 months, only to reopen the following June after major cleanup work has been done to ensure its safety for public use. Researchers can acquire significant insights into the nature of secondary succession by evaluating changes in the forest community over time using data gathered at the same 6 locations situated in Point Pleasant Park's most damaged sections. The significance of this research ranges from climate change to biodiversity loss. Urban green areas such as Point Pleasant Park are critical in resolving these issues. Point Pleasant Park provides urban inhabitants refuge, it sustains local wildlife, and it contributes to the well-being of urban populations. Most importantly, Point Pleasant Park is extremely valuable to the Mi'kmaq Nation, which are an indigenous people with profound historical links to the region. Recognizing the significance of this park to the Mi'kmaq people is critical in appreciating the larger context in which this research is set. Objectives. The primary goal is to research tree succession at Point Pleasant Park in Halifax, Nova Scotia following Hurricane Juan in 2003. This has been achieved by using three techniques. The first technique is the Shannon Diversity Index, which was used to analyze the total change in the forest community between 2004 and 2023. We hypothesized that there will be a large positive shift in the Shannon Diversity Index between 2004 and 2023. The second technique we will use is the density of dominant species at Point Pleasant Park. We hypothesized that the density of the dominant species at Point Pleasant Park will show a significant increase in density from 2004 to 2023. The third technique we will be using is regression analysis. We will use this to examine how species richness changes over time. We hypothesized that the species richness will show an increase over time. These techniques will be used to answer the following questions. How has the overall forest community changed over time? And what can we predict will happen to the overall community as the forest moves towards its climax community? How has the density of the dominant species in 2004 as well as the dominant species in 2023 changed over time? What can we predict will happen to the dominant species and the community metrics as the forest moves towards its climax community? The last question is how has the chosen community metric changed over time, and what can we predict will happen to the chosen community metric as the forest moves towards its climax community?
Point Pleasant Park in Halifax, Nova Scotia was chosen as the ideal study site for secondary succession due to the extreme damage post-Hurricane Juan, the even-age nature of the forest prior to the hurricane, and the shallow soil resulted in 70% of the canopy being lost in 2003. Data was collected from 6 study sites throughout Point Pleasant Park that were 400 meters squared in size. At each site, tree density per species and tree size was measured. All living trees greater than 2.5 centimeters at breast height, approximately 4.5 feet from the ground, were identified and measured using measuring tapes. Data was collected at the same 6 forest plots every year from 2004 to 2023, except for 2005 due to Hurricane Ophelia, 2007 due to Hurricane Noel, 2016 due to Hurricane Matthew, and 2020 due to the COVID-19 pandemic. This data was then used to calculate a variety of forest community metrics. Total density, Shannon Diversity Index, Pelos evenness, and the number of species were calculated for each site every year using density and tree identification data. Average diameter at breast height was also calculated at each site for every year the data was collected. Linear regression analysis was performed using data from each year to observe any trends on community metrics over time.
Results. overall forest community over time using the Shannon Diversity Index. Based on the graph shown on my right, we can see a very low slope value of 0.07, which indicates a slow rate of increase. The overall forest community has changed in a positive linear fashion following Hurricane Juan. The total forest community at Point Pleasant Park has seen considerable changes since the negative impacts of Hurricane Juan in 2003. The natural environment is gradually recovering to a more stable condition as time passes. While this process might take decades or even centuries, it is a natural mechanism that allows landscapes to recover and regenerate after large disruptions, eventually resulting in a diversified and resilient forest community. We predict that as the forest moves towards its climax community, it will become more stable, robust, and diversified, acting as a dynamic and ecologically beneficial resource within the urban landscape. Overall, we can accept our hypothesis based on the positive increase in the Shannon Diversity Index from 2004 and 2023. Also, we may expect more biodiversity and enhanced environmental stability as the forest moves towards its climax community.
To investigate how Point Pleasant Forest Community has changed since Hurricane Juan, we examined the relationship between the dominant species in 2004 and 2023 relative to time after the disturbance. It was predicted that the dominant species in 2004, red spruce, would show an increase in density over time. Results of linear regression analysis indicated that there was a weak but significant positive relationship between red spruce density and time. These results show that the increase in red spruce population is correlated with the increase in time after disturbance from 2004 to 2023, therefore supporting our alternative hypothesis. Though there is a significant increase in population density, the low slope value of 0.34 indicates that this growth is occurring at a slow rate, as shown in Figure 5. Red spruce is a very shade-tolerant tree, with a long life expectancy of 250 to 350 years. Therefore, it is expected that after disturbance, red spruce will have a much slower regeneration time, resulting in a slow increase in density over time. We also examined how the density of the dominant species in 2023, red maple, has changed over time using linear regression analysis. Similar to red spruce, we hypothesized that red maple would show a positive relationship between population density and time after Hurricane Juan. Linear regression indicated that there was a significant positive relationship between red maple density and time, supporting our alternative hypothesis that the population density would increase from 2004 to 2023 after the hurricane, as shown in Figure 6. A large slope value of 3.26 for density over time indicates that red maple had a high rate of density increase post-disturbance. Red maple is a moderately shade-tolerant tree with a lifespan of 80 to 130 years, as it has a rapid rate of development. The disturbance of the forest canopy during the hurricane likely increased light acquisition of lower forest communities, providing opportunities for species with less shade tolerance and rapid growth rates, like the red maple, to thrive. This destruction of the canopy allowed red maple to establish dominance over the dominant species in 2004, which was red spruce, in later years of succession. The increase in density of dominant species like red spruce and red maple over time is consistent with previous studies on the process of secondary succession from Burleigh et al. As the community moves through the stages of post-disturbance secondary succession, it is expected that larger canopy species like red spruce and red maple will continue to dominate the ecosystem and replace earlier established pioneer species. As such, one would expect to see a decrease in the rate of density growth over time as the Point Pleasant Park community approaches its climactic state and the community stability is reached. As the community approaches a state of equilibrium, these dominant species will outcompete other rare species, reducing the species diversity, abundance, and richness of the community. Consequently, metrics like Shannon Diversity Index and Pelu's evenness will also decrease.
We predicted that there would be an increase in species richness over time. Based off of Figure 7, species richness offers the best representation of regrowth over time. We used regression analysis to examine this. Species richness had a higher R-squared value of 0.6551 as compared to the Shannon Diversity Index, which was 0.3303, or the Pelu's evenness, which was 0.044. Although species richness tells us the number of all different species in the designated area and does not consider the abundance of the individual species, an R-squared value of 0.65 tells us that 65% of the change in species richness can be explained by changes over time. This means that there is a moderately strong explanation that tells us that over the given time period of 2004 to 2022, the variance or increase in species richness in Point Pleasant Park is simply caused by giving the park time to allow species to resettle and reestablish themselves. The slope of the line can also tell us the rate of increase in the species richness over time. Because it is a positive slope, we can infer that the species richness is increasing over time. The value of the slope being 0.6226 tells us that for each unit of time, in this case each year, the species richness is increasing by 0.6226 units. Between 2004 and 2018, Point Pleasant Park experienced a rise in species richness over time from an average of 2.5 in 2004 to an average of 11.6 in 2018. Thus, our hypothesis is supported. Although the overall inference from the data tells us that there is a relative increase in the species richness over time, as per the R-squared value and the slope, it is evident within the data points on the graph that there has been a subtle plateau in the species richness. In 2018, the species richness in Point Pleasant Park was at its peak, however, it has plateaued since then. This allows us to predict that as time moves forward, we may see a plateau of the species richness continue or even begin to decrease, which is consistent with mid to late stage successional theories. We predict that the Acadian forest in Point Pleasant Park is in mid to late stages of succession. We conclude this based off of the data provided from the field surveys. In particular, looking at the total density, there is an evident positive increase over the past 20 years in various species, both native and non-native. Population density of red spruce shows evidence of being in mid to late stage succession due to its slower growth rate, red spruce being the highest density population tree in 2004. As we approach over 20 years post-hurricane, we are now seeing the evidence of its gradual regrowth over time. We also see evidence of mid to late stage succession as we begin to note the high population density of red maples in Point Pleasant Park presently. It is evident that with the low shade coverage that resulted from the disturbance, the opportunity for the red maple to establish itself was presented, and we are seeing evidence of this as we approach over 20 years post-hurricane. Species richness is on an increase and can be strongly explained by its positive R-squared value, which shows the relatedness of increase in diversity over time. Urban forests have historically come with various limitations, such as reduced native species due to more aesthetically pleasing exotic species being planted in their place, as well as less fertile and more fragmented land for which native and non-native species may grow. Because of these fragmented areas, as well as their location within the urban environment, urban forests are typically more vulnerable to a high volume of disturbances. These factors in turn affect the variables such as species richness and evenness and threaten native species establishment in the forest. This allows for non-native species to take their place. After Hurricane Juan, many of the well-established red spruce were lost. This allowed for the regrowth of many other native and non-native species. The data shows that other non-native species such as European beech, English oak, European ash, Norway maple, Douglas fir, and many more are also common trees and shrubs found in Point Pleasant Park. However, although the species diversity and richness were considerably altered, the native species red maple was still able to establish itself. The recovery and management of urban forests can be enriched by the theory of two-eyes seeing, which is a research and development technique that incorporates considering the knowledge of indigenous practices and traditions as well as more westernized methods. Using both methods together may allow for a more in-depth personal and successful strategy for forest recovery and maintenance, pre- and post-disturbance. Robertson et al. Describes environmental narrative as the lived experience of individuals with their environment and their knowledge and wisdom gained by those personal experiences. They mentioned incorporating not only scientific and westernized knowledge in recovering degraded landscapes in Australia, but also local and Aboriginal knowledge as a meaningful and impactful strategy. According to Burley et al., in 2008, it was recommended that Point Pleasant Park be strategically thinned to create a more uneven-aged forest, because a more even-aged forest is highly susceptible to damage due to high-velocity winds and storms. This proposed measure allows us to predict that perhaps a more uneven-aged forest stands a better chance in withstanding high-disturbance hurricanes such as Hurricane Juan. Diassi et al. In 2017 states that in an uneven forest, the different heights of the trees allows for a more rugged area for which the wind must travel over, and thus it acts as protection against harsh winds.
How could your research inform conservation strategies in Point Pleasant Park and other similar plant communities? What suggestions do you have based on your findings? Understanding the effects of wide-scale disturbances on Point Pleasant Park and its pattern of recovery is imperative in the development of management tactics to maintain the biodiversity and sustainability of urban forest communities. Our findings indicate that after the destruction caused by Hurricane Juan, the plants of Point Pleasant Park are following the expected path of secondary succession. The increase in density of large species like red maple and red spruce, and the increase of species richness over time suggests that post-disturbance, the forest community is regenerating well on its own. Though Hurricane Juan resulted in a significant loss of biomass at Point Pleasant Park, our results show that disturbances like this can be beneficial to the ecosystem. An ecological survey of Point Pleasant Park in 1985 by Juan et al. Suggests that the selective thinning of the dominant canopy would be an effective management strategy to artificially promote natural succession, providing opportunity for new species to thrive. Prior to Hurricane Juan, Point Pleasant was a mature, even-aged forest, and our results show that the dismantling of the prevailing canopy had a positive impact on the biodiversity metrics of the forest, as the increase in light abundance to the forest floor provided opportunity for less shade-tolerant species, like the red maple, to establish dominance. The increase in the overall health of the community over time is shown by the increase of the Shannon Diversity Index in the time after the disturbance. In the future, once the climax community is well established, thinning of larger species that crowd the canopy may increase the species richness by fostering regeneration of less shade-tolerant species, mimicking the effects of natural disturbances and continuing the process of succession. Overall, the findings of this study suggest that at this stage of the succession, minimal interference is required, as the forest community of Point Pleasant Park appears to be following the predicted succession trajectory, as indicated by species density and richness metrics. However, continuing to monitor the succession process of the forest through studies like ours will be beneficial in ensuring healthy regrowth is taking place while letting the natural process of succession take its course.
How is our research significant in relation to climate change, and what aspects or effects of climate change may influence succession? Our research is significant in relation to climate change because it helps in the comprehension of climate-related ecosystem impacts, secondary succession as an ecological response, and assessing ecosystem resilience. A few specific aspects or effects of climate change that may influence succession are temperature and precipitation changes. Also, extreme weather events such as hurricanes, wildfires, and droughts may become more frequent and intense as a result of climate change. Also, climate change has the potential to impact succession by modifying environmental circumstances, species interactions, and the rate of disturbances.
Thank you for listening to our presentation. We would also like to thank the students from past years that participated in data collection, the teaching assistants of Biology 2060, the peer reviewers of this presentation, Dr. Allison Schmidt, and Dalhousie University.